Hi folks, welcome to the third video in your 10.2 lecture series. And here we're actually going to go through an example of what it means when we're finding an interval of convergence. Okay, so let's take a look at this example number one. The Taylor series at 0 for f of x equals e to the 2x. Okay, so this is the function that we're trying to find the Taylor series at, is given by this. Okay, so we know this is a series because we see all these plus signs. All right, so plus, 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 plus. I don't have like a comma, comma, comma like I did last time. I have a bunch of pluses. All right, now this is the most important part when we're reading through any of these questions. We want to scan through until we find the coefficient that has the ends. Now, you'll notice I didn't highlight the x to the n. I don't care about that part. I care about the coefficients. Okay, so scan through the problem, look for where that coefficient is with your n. They're giving you your a sub n formula. Okay, so like in all our other videos in 10.1, we were practicing finding them, but now someone is like, here is your coefficient. You just have to find it in the actual plus. Okay. So they're giving us our a sub n. And what we want to do is we want to compare our a sub n and our a sub n plus 1. Okay, so let's find them first, and then we'll look at what I mean when we say compare. Okay, so step 1, we're going to find our a sub n and our a sub n plus 1. All right, now the a sub n is pretty straightforward as long as you read through and you find the coefficient that has the n. In our case, that was 2 to the n over n factorial. Okay. Now we have to find our a sub n plus 1. And here's how we do that. Everywhere we see an n, we are going to replace it with an n plus 1. Okay. So a sub n equals 2 to the n plus 1 over, now I want it to be n plus 1 factorial, so it's going to be n plus 1 in parentheses, and then the factorial. Okay, so we're literally substituting everywhere there's an n, we're replacing it with n plus 1. Okay, now I recommend that what we do here is actually simplify or rewrite our a sub n plus 1. Well, that's supposed to say plus 1. Sorry about that. That we simplify this one first before we go to comparing them. Okay, here's what I mean by this. If you remember back to your exponent properties, 2 to the n plus 1 can be written as 2 to the n times 2 to the 1. And these two numerators say the same thing, but you'll see in just a second why I'm going to want us to write it this way. Okay. The other thing I want us to do is I want us to take this n plus 1 factorial on the bottom, and I want us to split it the way we did in that first video for this section, where we turn it into n plus 1 times n factorial. Okay. So we are splitting our numerator, and we're also splitting our denominator. All right. Again, it's going to make sense in this next step when we actually compare them. So step 1, find your a sub n and your a sub n plus 1. Step 2, we are going to find a sub n plus 1 over a sub n. Okay. When I take the ratio of these two things, that's what I mean when I say we're comparing them. Okay. So we've got this divided by this. Okay. So 2 to the n times 2 to the 1 over n plus 1 times n factorial. That's my a sub n plus 1. And I'm dividing it. Okay, so this is my a sub n plus 1. And I'm dividing it by my a sub n, 2 to the n over n factorial. this is my a sub n. Okay. So I'm finding them, and now I'm putting them into this massive fraction. Now, some of us are probably already feeling a little worried, but remember, when you're dividing by a fraction, you keep the first fraction, you turn the division into multiplication, and then you flip the second fraction, okay? And what that allows us to write is this: 2 to the n times 2 to the 1 over n plus 1 to the n factorial, okay? Times, now I'm going to flip my a sub n, so I'll get n factorial over 2 to the n, okay? So I still have my a sub n plus 1, and I'm still comparing it to my a sub n, but now I'm just like thinking about what it means to divide by a fraction. Now this might not look any better, but it actually is going to be super helpful because I can write this all as one fraction. Ready? 2 to the n times 2 to the 1 times n factorial, all over n plus 1 times n factorial times 2 to the n. And one of the things that has probably gotten you pretty far in your math career is that when you have something divided by itself, you're going to get 1. In other words, 2 to the n divided by 2 to the n is 1. And n factorial divided by n factorial is 1. And so even though it started off as a very complicated looking thing, what we're able to simplify it to is just 2 over n plus 1. Okay, look at how far that algebra got us. It's all just 2 over n plus 1. Okay, so after you find your a sub n and your a sub n plus 1, and after you find the ratio of the two, your next step, right, so step number 3, you are going to find your limit as n approaches infinity of your a sub n plus 1 over a sub n. Okay, this is what, and we'll go back in just a little bit to check, but this is what our textbook gave us. Like, this is what we're looking for. Because at this point, if we get a number, we know that there is an interval of convergence. If we get 0, it's going to mean that we have convergence everywhere. And if we get it equal to infinity, it means it just converges as at one point. Okay, so we're pretty close to being done here. Let's find the limit as n approaches infinity of, what did we say that was? 2 over n plus 1. 2 over n plus 1. Okay. Well, I'm going to go back to the ideas I did in that first video. The numerator has degree 0. The denominator has degree 1. And when we have a degree on the top that's smaller than the degree on the bottom, when we take the limit as n goes to infinity, we get 0. Okay? Last step, let's interpret our results. So yes, we did a whole bunch of stuff, but now we need to understand what that means. Okay, so we got 0 as our limit. So I'm going to go back to this. Okay, our cases. We have case 1. Did we get a number that wasn't equal to 0? Well, no, because we got 0. So it's not case 1. And we didn't get infinity, so it's not case 3. We got 0. So what that means is that my Taylor series converges everywhere. Okay? So when we go down to interpret our results, we're going to write that the Taylor series at 0 for f of x equals 2 to the x converges everywhere. Okay? So there it is all on one screen for you. Feel free to watch this again. In the next video, we're going to take a look at example 2.